Now example time for our organic nomenclature. So the first thing you're going to want to do is identify your longest continuous chain, and a couple different ways I could look at this. Maybe I want to say something like that. So there we have, how many carbons would we have in that case? 7. So we've got, and they're all single bonds. And you could have just done a straight chain. I was just trying to get goofy and show you that you don't always have to have it straight. But the longest continuous chain, regardless, would be 7, which is hept, all single bonds. So it's going to be ane. Well, we've got a couple of these guys to worry about. So where should we start numbering our chain? From the left or the right? From the left. So this is going to be number 1 up here. This is number 7 over here, which means we're going to have one coming off of number 2, another one coming off of number 2, and then off of number 5. Double check and make sure I did that right. So when we do this, when we name it, it's going to be 2, 2, 5. I know that seems redundant, but you've got to do that. 2, 2, 5. Then what would we say? Excellent. So don't forget your prefix. Trimethyl, I did not space that very well, but trimethylheptane. That would really all be one word right there. 2,2,5 trimethylheptane. Okay, next one. Notice the difference between these. Number 1 is a structural formula. Number 2 is a condensed structural formula. It's just two different ways of showing them. But found my longest continuous chain of carbon. How many? 5. So that's going to be pent. Looks like they're all single bonds. So it's going to be an ane ending, pentane. Does it matter which side I number from? No, it doesn't. So what number are we going to call that? Number 3. So it becomes 3-methylpentane. 3-methylpentane. Next one. There's our longest chain. How many carbons? 6 carbons, so hex. Is it 89? Ine. Hexine is the first thing we want to think about, how we have that ending, hexine. Where is our triple bond going to be located? Number 3. So that's the first thing I have to think about. And to be honest, that's the only thing I have to think about because I am now done. There's no alkyl groups coming off of there. So it's just a 3-hexine. And number 4. In this case, I'm going to go ahead and highlight my carbons. Notice they do this. So let's see if I can. There's my carbon bond, my double bond. So I've got some carbons up here, some carbons down there. When we count our carbons, we've got 3, 4, 5, 6, 7 of them. So that becomes hept. Hept what? Ene. And what do we want to number that heptene? Number 3, because that's where our double bond is coming off of. Are we done? It's gonna be a trans. And the question was, which side are we starting from? I would start from here because this is 1, 2, 3. There's your 3rd carbon. So if you started from the other side, you would have it be a 4. So that wouldn't be the appropriate side. Okay, so we have a trans 3-heptene. Number 5. What's this? Cyclopropane. That's it. Okay, number 6. Longest continuous chain of carbon. Could that be it? Absolutely not, because it has to contain that double bond, so we know that's not it. It is going to be right there. And how many carbons is that? 7, okay. So that's going to be hept, and the ending, ene. What else do we need to put in there? 1. What's a 1, right? So we've got this carbon right here, which is our first carbon where we've got that double bond. So a 1-heptene. Anything else? Okay. We've got an ethyl, and it's coming off of carbon number 4. So because I started this as being number 1, and this over here is number 7 for my carbon, I must keep that numbering system. Even if this ethyl group was way over here, I can't suddenly change my numbering system. Remember, your double bond takes precedence over making the lowest number, and then you have to stick with that numbering. So it becomes a 4-ethyl-1-heptene. Okay, are these kind of fun? Just a little bit. Okay, number 7, longest continuous chain. In this case, we have to make sure that we have our triple bond in there. So again, it's going to be like that, which means our longest chain is 6. So we are going to call that hexine, because there's a triple bond, so it's hexine. And the reason, the question was, why does it go down? So if I have 6 carbons here, if I were to change it and make it like this, maybe it's the same, but no, 1, 2, 3, 4, 5, it's only 5 carbons. So our rule says we have to make the longest continuous chain. So my finger is on the board, don't pick it up, and that's the longer chain. So that's why it's 6 carbons. So it becomes a hexine. And we still have these guys to take care of, which means it's coming off of our 3rd carbon. What are you going to name that? It's 2 carbons. Ethyl. So a 3-ethyl hexine. Okay, I was corrected. I left off my triple bond. Okay, so we've got our number 1 is where our triple bond is. So we've got a 1-hexine, and then we come back and we say that we've got that 3, the ethyl coming off of our 3rd carbon. So it's a 3-ethyl 1-hexine. And moving on. Now we're going to do it in the opposite direction. We're going to be given names of these guys, and we have to draw the pictures for them. So a cyclohexane. Sounds like we have 6 carbons that are just going to all be in a circle. And it's a hexane, so all I'm going to do is do a single bond on all of those guys. Now we just need to make sure that all of those bonds are correct and add hydrogens where we need to. Looks like each carbon has 2 bonds, so we need to give it how many hydrogens? 2. The easiest way, I would just do this. If you want, you can attach 2 hydrogens with little dashes, which is a little tougher maybe, and people always ask, well, do I put them on the inside or the outside? And it just doesn't matter. Put them wherever they fit the best for you. But that would be the easiest, to do a condensed structural formula. Okay, number 9, 3-methyl-1-pentyne. So we're going to start with this, pentyne. We're going to draw 5 of our carbons. I'm going to start with all single bonds, but it tells me it's a pentyne, and it's more specifically, it's a 1-pentyne. So what does that mean? Okay, so triples on the 1. I am a creature of habit. I typically start on my left-hand side. If I'm able to draw these, I usually throw my number 1s over on the left-hand side, but you can do whatever you want. So I've just taken care of the 1-pentyne. Now I need a 3-methyl. So if this is number 1 right here, then I have to have on number 3, I have to have a methyl group coming off. I'm going to go ahead and just make it easy like that instead of doing a bunch of little hydrogens with it. And so that's what our methyl looks like. So a methyl group is a CH3. So that's why we drew it that way. And now we just need to add in any of our hydrogens. So how many hydrogens needed to be added to carbon number 1? 1. Carbon number 2? 0. He's happy. Carbon number 3? 1. Number 4. 2. And the last one. 3. And you can draw your dashes, or if you want, notice what I just did was I kind of mixed a condensed structural formula with a structural formula. That is okay. Whatever you think makes the neatest, most legible, readable structure would be fine. And I kind of mixed them together. Okay, I love number 10. Okay, number 10. A butene. We're making a butene. So how many carbons? 4. 1, 2, 3, 4. But it's an ene, and it's a 1-butene. So I'm going to go ahead and put that double bond right there. Now I have to throw in some methyls. So think about where you'd throw those. I have to have one off the number 3, another one off of number 3, and another one off of number 4. So that is what it looks like. It doesn't matter if they go up or down or off to the side. It doesn't matter at all. I'm going to go ahead and throw in some hydrogens. So this carbon needs 2 hydrogens. This carbon just needs 1. Again, it doesn't matter if I put them on the top or the bottom. My third carbon here is pretty darn happy. My last carbon needs how many? 2. I'm just going to do that. All right. Is everybody happy with that drawing? There is something very, very wrong with this drawing. In fact, so wrong that that's not the real name of that thing. So the drawing actually is correct. It's the word that's the name of that compound is incorrect. There we go. You found it. So longest continuous chain of carbons. There's more than just 4. You've got 5 carbons or your long chain. So in this case, you have to still call this your number 1 because that's where your double bond is. So when we name this, it ends up really being a, let's see, we'll do it step by step. It's going to be a pentene, and it's going to be a 1-pentene, and you have methyls coming off of 3, 3, and that's it. So it's going to be a 3, 3 dash dimethyl dash 1 dash pentene. That's a good one. That's similar to, on your homework, I don't remember exactly what numbers, 37-ish maybe. There's a couple in there that you have a similar thing where you're supposed to draw it and rename it because it's actually incorrect. So it would be something similar to what we see there. Okay, we have 2 more. Okay, last couple. Here we have 2-methylpropene. And for this, we are going to draw 3 carbons, 1, 2, 3, and it's a 2-methylpropene. We don't have any mention of where that double bond is. You would expect normally to see a number in there, but why? Because it's got to be on the first carbon. There's no other possibility. If it was here, I would even still call that carbon number 1. So I'll keep it right there, and we're going to have a 2-methyl coming off right here. There's my methyl group. So now I just throw in my hydrogens. This carbon, middle carbon is happy, and he needs 2 more. And that is it, our 2-methylpropene. And last one we have is a cyclopentane. So I have to make 5 carbons. And it is a pentane, so I just made all single bonds. And I have a methyl group coming off of number 1, 2, and 4. Where do we choose number 1? It just doesn't matter. So let's say I'm choosing this guy as number 1 right here. Then I'll have a methyl group coming off. If that's number 1, and let's say I'm going clockwise, but you can choose, it doesn't matter. And then number 4. So the only other thing we have to do is just throw in some hydrogens to make it all work out. So each of those groups that has the alkyl group coming off of it needs 1 hydrogen. And the other guys, you know what? I didn't do that right. Sorry. Looks like I was not noticing my spacing very well. So here's 1, 2, and this is 4 over here. Okay, so which means the other 2 carbons have to have a hydrogen each. It'd probably be better to just keep those hydrogens on the outside. There's more room. But that is it. You have finished organic nomenclature.